Hi everyone, we are talking about applications today, using everything that we've learned so far. So first, a little bit of notation. We typically don't use this. I've never used it this way, but I've been told that in engineering sometimes it does come up, so it's important to know about degrees and then minutes. Okay, so think about a clock. If they give you the minutes, then it's just telling you how much out of 60 this is. It's an alternative way of writing decimals. So in this case, if we have 35 degrees 24 minutes, that would mean 35 and then 24 sixtieths of a degree, so 35.4. Okay, so just for practice, if we have 115 degrees in 36 minutes, that would be 115 degrees plus 36 out of 60 minutes. Okay, so 115.6. For 14 degrees and 10 minutes, that would be 14 plus 10 over 60, so 14.166 degrees. Okay, just to recap, when to use law of cosines, when to use law of sines. So if you have more side lengths, a law of cosines is great. If you have more angles, law of sines is great. So if you have 2 angles, that means you have 3 angles. That means law of sines is probably going to be good. That being said, you probably still need a side length, but law of sines is easier to use if you have more angles than sides. Law of cosines is great if you have more sides than angles, especially if you have 3 sides and no angles, then you must use law of cosines. And that's when this will come into play. Alright, so first example, we have little Susie. She sees a dog sitting on the sidewalk, and the angle of depression, get it? Because it's lost. Okay, the angle of depression from the window to the dog is 46 degrees 42 minutes, and Susie's window is 24 feet above the sidewalk. So we're going to assume that this is a right triangle. Her window is 24 feet up, and this angle right here is 46 degrees and 42 minutes. And we want to know how far Susie is from the dog. And we'll draw Susie. Actually, I'm going to make her sad. Okay. So solving this, I can use cosine because I have an adjacent and a hypotenuse is what I'm solving for. So cosine of, I need to convert this into a decimal to make this usable for me. So that would be 46.7 is equal to 24 over x. Alright, solving for x, make sure you're in degrees in your calculator. I get 34.994. Alright, next one, you're swimming 4 kilometers per hour with your body perpendicular to a stream and the current of 3.5 kilometers per hour. What is your speed? What angle are you making with the current? So the way that I'm interpreting this problem, because they told us the speed and they told us the angle, but the way I'm interpreting this is you're trying to swim 4 kilometers per hour is your output, and you're trying to swim perpendicular. That's the idea. That's what the direction of your force. So if we have a stream, let's say you're trying to exert a force of 4 kilometers an hour perpendicular to the stream. If the stream is pushing you 3.5 kilometers an hour, and so you're actually exerting a force in this way. Okay. And I'm interpreting the angle to be right here. So this will be theta and this will be x, and those are the 2 variables that I'm solving for. So to solve for theta, I can just set up tangent. Tangent being 4 over 3.5. So tangent must be 48.814, which makes sense. Okay, and then solving for x, I can just use the Pythagorean theorem. So x must be 5.315. Alright, moving on. Alright, next example, I have a rocket shooting straight up from a launch pad. So that tells me that this is going to be a right angle. 5 seconds after liftoff, I note that Fred, standing 2 miles away, says that the angle of elevation is 10. 4 seconds after that. Okay, so after 9 seconds has elapsed, I note that Fred, who's still standing 2 miles away, sees the angle of elevation is 38. So I want to know how far the rocket rose during the 4 seconds between 5 and 9. Right, so if I call this x and if I call this distance y, what I'm looking for is y minus x, or the difference in distance during these 4 seconds. So I can set up two different equations here. I can use tangent because I don't know my hypotenuse. So that means tangent of 10 is x over 2. So x is 2 tangent of 10. Here I know tangent of 38 is y over 2. So y is 2 tangent of 38. So y minus x is going to be 2 tangent of 38 minus 2 tangent of 10. Plug that in your calculator and make sure you're in degrees. We get 1.209 miles, meaning the rocket rose in 4 seconds, 1.209 miles. Alright, now give this next one a shot, so go ahead and pause the video, see if you can work this out, and then if you get stuck, you can see what I did. Okay, so the idea is we have an angle here, 21 degrees. Okay, we flew 100 miles. We end up 70 miles afterwards, being back on course. Okay, and then I have some theta here that I'm solving for. Okay, now I have a few issues here. Mainly, I really need to know this distance, okay? Because if I end up setting up a proportion, so if I end up setting up, let's say, law of sines. So in this case, my angle here, I just subtract from 180. So 180 minus 21 minus theta. So 159 minus theta is 270, as sine of theta is to 100, the sine of 21 is to x. Right, so I have too many variables here. I can't solve this equation out. Now what I can do is solve for x using law of cosines. Okay, so I know that x squared must be 100 squared plus 70 squared minus 2 times 70 times 100 cosine of 21. Alright, solve this, don't forget to square root, and I get that x is 42.777. So now in my ratio here, I know that this is 42.777. Now I can solve for theta. So now I can cross multiply here and use arcsine to solve for theta, meaning that theta will be 56.904 degrees. Alright, that is it for these notes. That's it for this chapter, actually. So if we move down after this practice, we have a review for the entire unit. So after you do your worksheet, give this a shot and let me know if you have any questions. Hey, otherwise, I will see y'all later.